Welcome. This presentation is about the crime in the city of Chicago. Starting off with the fictional context for the presentation. We are a boutique analytics firm and we have been approached by Chicago Police Department to look at their crime data and build an informative model. Our analysis could be used to educate various government entities about the ground reality situation and equip them with knowledge which they can use to implement short-term and long-term policies for a crime-free Chicago. Let's start with an overview of the work we did. In the first part, we specifically considered the crime dataset obtained from Chicago Data Portal as our base data. We had to clean and normalize the data in Python to effectively perform an exploratory data analysis in Tableau. Through our visuals, viewers would be able to know the general trends in crime and identify the problematic locations in the city. To bring a deeper insight, we augmented the base data with socio-economic datasets of education, income, and hardship index, etc. Here, we observed significant correlations which gives an indication of possible factors influencing crimes that could be studied further for causality. We further validated our findings with live Twitter data as analyzing the community level tweets can give us an idea about the underlying feelings of the residents. We could not use streaming data as these generate limited geographical details. Therefore, we went ahead with the Twitter Geo Search API to get geographical data originated in Chicago. We then uploaded the data into Hive and calculated the distance of each tweet from the different community focal points and attributed the closest community to each tweet. We then performed text mining on the geotag tweets to identify collective 5 levels of sentiment tags, from angry to blissful. This analysis corroborated our previous hypothesis about the high crime rates in certain areas and the possible factors that influence crimes. So without further ado, let's dive into the actual analysis.
We started with this animation where the x-axis is representing the years and y-axis number of crime cases. This animation is for the 4 communities, and as we see the vertical movement of bubbles is representing quarters and the horizontal movement is representing years. And as you see, there is a seasonality involved in this trend, and crime is decreasing over the years for these 4 neighborhoods. Now, we wanted to know what are the safest and the unsafest days of the weeks. As you can see, most of the crimes occur on Friday, and so it's the worst day of the week, and Sunday is the safest of all the days. Now, by crime by time of day, we see that it ranges from 76,000 to about 333,000 cases, and most crime cases occur at night, especially from 8 p.m. to midnight. It was very interesting to see that crime follows a cyclical pattern for days of the week as well as for time of the day, and it keeps decreasing over the years. Our next question was, does temperature have an effect on crime? The vertical axis is representing the average temperature as shown by these red bars, and the blue line is representing the number of crime cases. This plot clearly tells that as summer approaches, number of crime cases increase, and then there is a sharp decline in crime. So yes, temperature does have an effect on crime. So our short-term recommendations are to increase patrol hours during these critical hours or days, and also make aware the residents of Chicago about these hours. Now, we wanted to dig down to zones and community level. There are 10 community zones in Chicago, and we found that northwest side is the safest and west side is the unsafest neighborhood zones in Chicago. And the right map shows the number of records, and the intensity of color represents the number of cases. And as you can see, although there are 77 communities in Chicago, Austin is the most unsafe community with about 100,000 violent crimes over the years. So the big question is, why are certain areas more susceptible to crime than others? And for this, we have three hypotheses. First, is education correlated with crime? Second, is income correlated with crime? And third, is hardship index, which is represented by housing, crowded housing, poverty, unemployment, education, dependency, and income, correlated with crime. So here, for our first hypothesis, we want to see the effect of education on crime. On the x-axis, there is population with less than high school diploma, and y-axis, number of crime cases. And we can see there is a weak correlation between these two variables. On the other hand, income has a high correlation with crime. On the x-axis, there is population with earning less than $25,000 a year, and y-axis, number of crime cases. And as you can see, as the impoverished household increases, the number of crime cases tend to decrease. Austin is a clear outlier here with a very high rate of crime, even among communities with higher population of lower income. I want to mention here that correlation doesn't mean causation, and there might be a lot of other factors involved in the increase in crime in Chicago. Next, we divided the total population by ethnicities: Asians, Caucasians, African Americans, and Hispanics, and we found that for African Americans who are earning less than $25,000 and for Hispanic, there is a correlation between crime and income. The next hypothesis was, is crime related to hardship level? And we found, yes, there is a weak correlation between hardship and number of crime cases. Austin, again, here is an outlier. So our long-term recommendations are to generate more employment opportunities for unfortunates, and also increase collaboration between various communities, provide therapies, and housing for homeless.
Now that we've seen trends and correlation, let's see if we could validate this with any live data. Dr. Bill McCarthy, a renowned specialist from UC Davis, wrote a seminal paper on the relation between happiness and crime. He argues that the program and policies that increase happiness have a notable effect on deterring crimes, especially nonviolent crimes and drug use. Many explanations of decisions about crime focus either on the reflective thought that discourages offense or negative emotions that contributes to it. And what better way to gauge the negative or positive emotions of individuals and collective sentiments than the information available on the social platforms onto which some people literally echo their thought 24/7. Therefore, we extracted and analyzed 1 week worth of tweets from Chicago communities and tried to understand the hidden feelings behind the message between the spectrum of anger and blissfulness through text mining. It's a similar technique which your phone uses to understand the email and auto-suggest a reply. Let's take an example of Austin from the western part of the Chicago. So when we click on Austin, we could see the word cloud of all the prevalent words emerging from that region. Austin residents' tweets feelings are generally in the bracket of anger and despondency, and these underlying feelings tends to translate into antisocial behaviors, which we had talked about earlier. In contrast, neighborhood tweets from areas like near North Side on the eastern Chicago and the Lincoln Park are in the bracket of blissful and contentment, which indicates a positive outlook on life and hence translates to relatively much less crimes happening in those communities. By no means this words cloud represent a democratic single voice of a specific community, as this doesn't hold true for other communities, but as a means of moral thinking, this truly deserves a strong consideration. To summarize, through our explanatory studies, we found a trend which should give you a ground reality of Chicago trends. Our correlation analysis highlights the interaction and interconnection between the socio-demographics factor, and if given more time and resources, could be compared with cities like San Francisco, which can actually provide a baseline input to state level and federal level governments. Through Twitter integration, we can see an interaction of micro feelings building up to a macro trend, and if given more time, we can integrate other API sources. With this summary, I conclude my presentation. Thank you.